Hi children and viewers. In this video I am going to explain about the dimensional formula. What is mean by dimensional formula and what is the dimension and what is the dimensional equation. Children, this is the one of the most important topic. That's why you have to watch the video very carefully. Every student must be know what is the dimensional formula and what are the uses of dimensional formulas in our physics. So every student must learn about this one, that much of important. So here most probably it is very important topic for IPE, intermediate public examinations. At the same time this topic is very important for other competitive exams like MSET, JEE and NEET and IIT also. So that's why here you must learn the dimensional formulas and must have to gain the knowledge about the dimensional formulas. That's why if you can understand this topic, you can easily write the dimensional formulas for all physical quantities. You may feel it is little bit difficult, then you are unable to write the dimensional formulas. So I will explain the all the dimensional formulas in a simple way. So you have to know, first you have to know what is dimensional formula, how we can write that. Before going into that, children, first you have to know what is the dimensional formula and what is the dimensional equation. You must know about the difference between these two. Here let us see, here there is one definition on the board for dimensional formula and dimensional equation. Children, here the first thing is dimensional formula. Watch carefully and listen carefully. The expression which show how and which of the base quantities represents the dimensions of a physical quantity is called the dimensional formula. The expression which show how and which of the base quantities represent the dimension of a physical quantity is called the dimensional formula. The expression which show what it can show how and which of the base quantities represent the dimensions of the physical quantity is called the dimensional formula. Dimensional formula is nothing but it is a expression. It is a expression. In that expression what you have, base quantities are used. Base quantities are used to explain the dimensions of a physical quantity. Clear? The expression which can be used to explain the dimensions of physical quantities by using the base quantities, that is what we call here dimensional formula. No need to get confusion. I will explain one more time. Okay. And now here one word it is there. What's that? Base quantities. Base quantities. Base quantities means generally the quantities which are independent of others. The physical quantities, general in physics, physical quantities means what? Line, length, velocity, speed, mass, acceleration, force and so many things, torque, pressure, and what we are saying that all are physical quantities. So generally we can say that mass, it is a physical quantity, velocity, it is a physical quantity. Clear? Like that, the physical quantities which are independent of others, they are called base quantities or fundamental quantities. The physical quantities which are independent of others. Independent of others means what? They are not depending upon any other quantities. That type of quantities are called base quantities. So these base quantities are used to explain the dimensions of physical quantities. So these are expressed in an equation that should be called here formula. Expression. Here the expression which show how and which of the base quantities represent the dimensions of a physical quantity is called the dimensional formula. Clear? So for example, here one example I gave, that is here volume. Here what is that? Physical quantity. Physical quantity, what is? Volume. For that volume, the dimensional formula should be taken as m to the power of 0, L cube and t to the power of 0. Now m0, L cube and t to the power of 0. Now this is called dimensional formula of volume. Clear? m0, L cube, t to the power of 0. Now it is called dimensional formula. Dimensional formula of volume. According to our definition, here the volume is what? Volume is physical quantity. Volume is the physical quantity. Here the physical quantity can be explained. Here mass, length and time. These are called base quantities. What do we call? Base quantities. Clear? The physical quantity can be expressed by using some base quantities like mass, length, time. Here the physical quantity volume can be expressed by using some base quantities with some dimensions. Here 0, 3, 0. M to the power of 0. Here what you have? M to the power of 0 and L to the power of 3 and T to the power of 0. Here 0 is the dimension of m. 0 is dimension of m and 3 is the dimension of L and 0 is the dimension of T. That means here 0, 3 and 0. These three are the dimensions. What do you say? Dimensions. Clear, children? According to the definition of dimensional formula, the expression which can, how and which explains the dimensions of physical quantities. Dimensions of physical quantities are by using some base quantities. By using some base quantities. So children, like this, here the volume dimension formula should be, volume is the physical quantity, physical quantities dimension formula should be expressed like this: m to the power of 0, L cube and t to the power of 0. Here m, L, t, that means base quantities. That means here the volume can be explained by using some base quantities and with their dimensions. With their dimensions. That should be what we call dimensional formula. So children, no need to feel nervous. I will explain now how we can write the dimensional formulas. So don't think about here how we get the m, L cube, t to the power of 0, m to the power of 0, L cube and t to the power of 0. How we will get the dimensional formula. Up to now, just stop it, that thinking about that one. After explaining this definition, I will go for that. So then you can get the clarity. Clear, children? That's why here simply now this is the dimension formula of volume. So that means by using the base quantities, we are writing the physical quantity expression in terms of base quantities and their dimensions. That is what we call dimensional formula. And now children, dimensional equation. What's that? Dimensional equation. So here an equation obtained by equating a physical quantity, by equating the physical quantity with its dimensional formula is called the dimensional equation. So before that I told you what is that? Volume, its dimensional formula is m to the power of 0, L cube and t to the power of 0. So here this is now dimensional formula and this is the volume. Now here you can keep like this simply: volume is equals to, we are using the symbol equals to, volume is equals to m to the power of 0, L cube and t to the power of 0. So here we are equating these two. When we have equation symbol, now it is the equation, and that equation explains what? Dimensional formula of physical quantity. This equation can explain about the Dimensional formula of physical quantity. What is the dimension formula here? Volume. And what is the dimension formula? M to the power of 0, L cube to the power of 0. That means that the equation which can represent the physical quantity and its dimension formula in a equation. That equation is what we call dimensional equation. What we call dimensional equation. The equation in which physical quantity should be equal to its dimensional formula. We are writing that dimensional formula is equals to its physical quantity, or physical quantity is equals to dimensional formula. That should be what we call, children, dimensional equation. So children, this is about the what is mean by dimensional formula and what is mean by dimensional equation. So now we have to learn how we can write the dimensional formula and units. So very important, children. So that's why here you have to watch carefully. Children, already you may have idea about the base quantities. Base quantities what? Base quantities means the quantities which are independent of other quantities, they are called base quantities. Base quantities also known as fundamental quantities. Fundamental quantities. So children, here there are some base quantities are there. Here I am showing that mass. Mass can be identified with the capital letter and that should be kept in the square brackets. Now here m is the dimensional formula of mass. Here I am writing now base quantity. Base quantities, these are the base quantities here. Base quantities are used to write the dimensional formula. Here mass can be shown with the capital M within the square brackets. Now capital M is the dimensional formula of mass, children. And here what is the dimension of mass here? Dimension of mass, what it is? Here we are writing M. We are not giving anything on above the letter M. That means what? What you have? 1. If there is anything, we have M to the power of 0 and we will show M square. And it is means by what? M. That means what? There is 1. There is 1. That's why here mass is capital M dimensional formula and dimension of mass is how much? Here 1. Because there is nothing above the letter M. That's why we are simply saying that is 1. And next thing here we have another base quantity, that is length. What's that? Length. So length also shown like this, capital L. Capital L. So same thing, capital L is the dimension formula of length. Capital M is the mass dimension formula. So here this is simply L. Simply what is say? L, capital L. If it is kept in between square brackets, now this is the dimensional formula. So that's why here while we are writing the dimensional formulas, the physical base quantities with the dimensions, that must be kept in between the square brackets. Okay children, and now here next third one here, length is L. Again there is nothing above the letter, that's why here what you say, its dimension is 1. Clear? And now we have, so next one is here, third one is time. So time, that should be mentioned, its dimension formula should be like this, capital T. And now again there is nothing above the letter T, that's why its dimension is 1. Clear? Up to now we discussed 3 base quantities or fundamental quantities. First one is mass, next one is length, and third one is temperature. M is the dimension formula of mass, and L is the dimension formula of length, and T is the dimension formula of time. And children, we have some other quantities also there, but we required only some of them. Next thing here, we have another thing is there, that is thermodynamic temperature. thermodynamic temperature. This is the another base quantity that should be mentioned in terms of kelvins. In terms of kelvins. And next thing here, current electricity. What do you have to say? Current electricity. Current electricity that should be shown with the letter capital A, ampere. What's that? Ampere. And next thing is here current electricity is A, and next thing is amount of substance. Amount of substance. Amount of substance that should be measured in terms of moles. What do you say? Mole. M-O-L, mole. And 7 here we have luminous intensity. Luminous intensity. That should be having some unities like this here, candela. So most probably we can use 5 only. Children, in dimensional formulas in the first year, maybe I think up to first year and second year in intermediate, you require here up to 1 to 5. So that's why first you have to know. To write the dimensional formula, first you have to know about the two things. First thing is, what is the relation of the quantity with other quantities? Nothing but that is the formula. And second thing, we must know about the what are the base quantities and what are their dimensions or dimensional formulas. So you must know about those things. Then only you can easily write the dimensional formula. So children, here now base quantities, here we have taken 5. For mass, capital M is the dimensional formula. For length, capital L, time T, and thermodynamic temperature is K, and current electricity is A. Current electricity is A. So here we are taken, these are the base quantities and their dimensional formulas. So now here how we can write the different dimensional formulas for different physical quantities, and based upon the dimensional formula how we can write the unit of the physical quantity we have to learn. First thing is how we can write the dimensional formula for physical quantity. That's the first thing. And based upon the dimensional formula how we can write the its unit. It's a unit. Let us discuss. So children, watch carefully. Maybe the video is very lengthy, but you have to pay much more attention to understand the concept. Clear, children? So here first thing is I am taking now PQ. PQ means physical quantity. What's that? Physical quantity. This is the physical quantity first we are taken. This is what? Physical quantity. And next thing is formula. What's that? Formula. I am going to write here. This is the formula. And now third one is dimensional formula. How we can write? Dimensional formula. And finally I am going to write units. By using the dimensional formula how we can write the units of the quantity. Clear, children? So watch carefully. First here I am going to write the dimensional formula for area. Physical quantity is now here. What is that? Number 1. Serial number is what? Area. Area is the physical quantity here now. This is the serial number. Physical quantity is area. For area, formula is what? Area is equal to, I am writing L into B. L into B. Length into breadth. Length into breadth. So here now you have to notice that area is equal to L into B. L means what? Length, and B means what? Breadth. Children, you have to observe now length into breadth. Length can be measured in terms of centimeters and meters, and breadth also measured in terms of length. And here I am writing L. L is what? Length. Length should be measured in terms of CGS, centimeter. In terms of SI, what do you write? Meter. And now in case of breadth also, that should be measured in terms of centimeter or meter. That means we are saying something centimeter and meter, or centimeter and meter. That means what? Centimeter is nothing but here length. Meter also length. That's why for length, which physical quantity used as dimension formula? Which symbol we have? What is the dimension formula of length? L. For breadth also nothing but it is length. That's why here we are taking now dimensional formula for area. That's here I am writing here for area what we write, length into breadth. So for length also we are having L, and for breadth also we are having formula, dimension formula L. Clear children? L, length measured in terms of centimeters. That's why length is already we know that dimension formula of length is what? L. Breadth also measured in terms of centimeters and meters. That's why we will take dimension formula again L. So here L into L. So what we know, when bases are equal, and they are in multiplication, when quantities are in bases are equal and they are in multiplication, obviously here what you have to say, when they are having same quantities and they are in multiplication, then what you have to do, we have to do the addition, adding of exponents and adding of powers. That's why here nothing there, that means what, 1 is there, and here also 1. L into L means what we write? L square, like that. Here L to the power of 1 plus 1, that is what? L square, or L to the power of 2. Here L to the power of 2. Here now children, here L to the power of 1 plus 1, and that is L square. So now here L square is the dimension formula of area. What is that? Dimension formula of area. So here area dimension formula is what? L square. And what is the dimension? 2. While in a dimension formula, the powers what we are writing, those powers should be named as the dimensions. Clear? In a formula, while we are writing the dimensions, the dimension represents the what it is? Power, or power represents the dimension. So here now simply this is the L square. L square is the dimension formula of area. And children, that should be also mentioned like this: m to the power of 0 and L square and t to the power of 0. Here what you say? This is right or wrong? Correct. M to the power of 0 means what? 1. And t to the power of 0 means what? 1. Then what do you get? 1 into L square into 1. That means what do you get? L square. That's why here, while you are writing the dimensional formula for any physical quantity, we have to use the base quantities like mass, length and time. Then here you have to write like this. Now m to the power of 0, for example, if anybody can ask what is the dimension of mass in the dimensional formula of area. Dimension formula of area. For example, here what I told you, L square is the dimension formula of area. L square is the dimension formula of area. For example, in competitive exam or anything, if anybody can ask you what is the dimensional formula or dimension of mass for area or dimension formula of area, then what you have to say? Simply you have to say L square means what? M is 0 and T also 0. Like that we can clearly explain that. That should be like m to the power of 0, L square and t to the power of 0. So here this is the dimension formula of area. And children, here L, what is L? Length. Length can be measured in terms of meters. Length can be measured in terms of meters. Then L square means what? Meter square. What, right? Meter square. That's why based upon this L square we are writing the now unit is meter square. What is that? Meter square. So now simply here we are writing this is for area. Clear children? So now we got, maybe I think you got idea about the dimension formula. To write the dimension formula, you must know about the first what is the formula. In our textbook, that should be mentioned the relation of the physical quantity with other quantities. Formula should be mentioned like this. the relation of the physical quantity with the other quantities. So that means when we have idea about the formula, we can easily write the dimension formula. Clear? And next children, I am taking one more example for you. Now it is volume. What is volume? Here again, what right children? Volume is nothing but L into B into H. L into B into H. So children, length that should be measured in terms of meters. Breadth that should also measured in terms of meters. And height also that should be measured in terms of meters. That's why length, breadth and height. Length, breadth and height. These three are having same dimension formula, that is L. That is L. Previously what I told you, length into breadth. For length it is L formula, dimension formula L. For breadth also dimension formula is L. Now here one more addition, what is that? Height. So height also having same dimensional formula. That's why here we are writing L dimension formula for L. And again for breadth also L. And this also L. Then what is children? That should be nothing but here L cube. What's that? L cube. L to the power of 1 plus 1 plus 1. So simply what you have? 1 plus 1 plus 1. Then what do you get? L cube. So it is the dimensional formula for volume. Dimensional formula for volume. So children, here I already told you what's that. This is also can be expressed in terms of like this: m to the power of 0 and L cube and t to the power of 0. M to the power of 0, L cube and t to the power of 0. M to the power of 0, L cube and t to the power of 0. M to the power of 0 means 1 and t to the power of 0 also 1. That's why now what you have to say, m to the power of 0, L cube and t to the power of 0. This is the dimension formula of volume. I think now you got the idea about the dimension formula of volume, what we discussed while the definition of dimensional formula and dimensional equation. So here again what you have to say, when we have L square, the unit is what? Meter square. Now here we have L cube, that's why unit is what? Meter cube. Meter cube is the dimension formula of m cube. And next thing children, I am going to write one more thing here. Now speed, physical point, what we are taking? Speed. Children, most important dimension formulas. So you have to got idea of. Children, what is speed and what is the formula for speed now children? For speed what you have to write children? Speed is equals to, simply I am writing directly formula, speed is equals to distance by time. What is children? Speed is equals to what? Distance by time. Distance by time. Distance nothing but length. For length what is the dimension formula? L. And time, I already explained what is the dimension formula of time? Capital T. For distance, length L, and for time T. That's why here what we write? Speed, we have quantities, what is that? Speed. And now here what you have? Formula is there? Distance by time. For distance what we take? Length L. What is that? Length L. And time is what? I already told you what's that? Dimension formula must be within the square brackets. That's why L by T. What to write? L by T. So here I am writing, this is the T. T is the dimension formula of time. And distance is nothing but length. What to write? L by T. And now here we are bringing L to the, like this L, and we are bringing the T to the top here. Now how we can write? T inverse 1. T inverse 1. So like 1 by x is equals to what, right? X inverse 1, like that. 1 by t means what? T inverse 1. Now here children, we will write LT inverse 1. LT inverse 1. Here inverse 1, LT inverse 1, LT inverse 1 is the dimensional formula for speed. LT inverse 1. Tell me now here, if anybody can ask you like this, LT inverse 1 is the dimensional formula of speed, then what is the dimension of T? What is the dimension of T? What I told you, the powers what we are writing, those can be called as the dimensions. That's why here the dimension of time is what? -1, and dimension of L is what? 1. Clear? LT inverse 1. Here children, by using that formula, dimension formula, I am going to write the dimensional formula. Based on that, I am going to write unit now here. For L, length, unit is what? Meter. And T is what? Time. For time, unit is what? Second inverse. What's that? Second inverse. Meter, second inverse. Clear? Like that. And now here I am going to explain few more dimension formulas. Children, lot of dimension formulas there in our textbook. You have to follow the same process. You have to follow the same process, children. That's why you don't bother about the dimension formulas. So if you can watch the video very carefully, you can easily understand that's what I am explaining and how we can write the dimension formulas. Children, now here speed is there. What's that? Distance by time. Now children, here I am going to write velocity. So the physical quantity what we are taken? Velocity. What is velocity? Velocity is nothing but, here we are writing displacement by time. Displacement by time. Here speed is what? Distance by time. Speed is the scalar quantity and velocity is what? Vector quantity. Displacement by time. Clear children? So what I told you, displacement by time. Displacement by time. Displacement is nothing but length. Yes, yes or not? Yes. Displacement is nothing but length. And time is T, capital T. That's why here again what to write? L by T. So here we are writing L by T. So here what you observe, L by T means what? LT inverse 1. LT inverse 1. Clear? That means what I will say? Velocity and speed. Velocity and speed both are having the same dimensional formulas. LT inverse 1. So here children, units also same. Meter, second inverse 1. For length, meter, and time, second inverse 1. Meter, second inverse 1. Clear? And after that children, here now I am going to write one more thing here, that is acceleration. Children, most important dimension formulas. Okay? Acceleration. Children, here what is acceleration? Change in velocity. Change in velocity by time. Already we know that. What is acceleration? Acceleration means what? Rate of change of velocity. Rate of means what? Change in velocity by time. Change in velocity by time. Children, change in velocity by time. Change in velocity is nothing but velocity. Change in velocity is nothing but velocity. That's why here change in velocity is nothing but velocity. Change in velocity means nothing but velocity. Already velocity dimension formula is what? LT inverse 1. Velocity what it is? LT inverse 1. That's why children, here what you have to observe? Change in velocity by time. Here this is the T again. Then what are children? L, T inverse 1, and this is also T inverse 1. Then what do you get children? LT inverse 2. Clear? -1 plus of -1. -1 -1 -2. That's why here what is the dimension formula? LT inverse 2. What's that? LT inverse 2. Clear? Acceleration is nothing but velocity by time. Velocity by time. Already we derived dimension formula. LT inverse 1 is the dimension formula for velocity. By using that, we are writing LT inverse 1 by T. That means what? LT inverse 2. That's why children, here from these two what you have to observe, dimensional formulas. The dimensional formula of physical quantities should be depend upon on one another. That means what here? Acceleration, and this is the velocity. Acceleration depend upon what? Velocity. That's why here acceleration is called dependent quantity or derived quantity. What, right? Derived quantity. Children, same thing here. Velocity is displacement by time, and speed also distance by time. That means speed is depend upon distance and time both. Acceleration depend upon change in velocity and time. That means here velocity, acceleration and speed all are what you have to say derived quantities. Derived quantities because they depend upon on others. Derived quantity means what? The physical quantities which can be depend upon other quantities. They are called derived quantities. They are called derived quantities. That's why children here, that's why we are writing formula means what? Velocity depend upon the displacement and time. Here displacement and time, these are the base quantities or fundamental quantities. That's why velocity is derived quantity. So okay, leave that children. Acceleration is what? Change in velocity by time, and change in velocity is here what? LT inverse 1 and time is t. Then what do you get? LT inverse 2. So children, from that what right? L is unit, what is that? Meter, and time what right? Second inverse 2. Meter second inverse 2, or it is also called as meter per second square. Meter per second square. So this is the dimensional formula for acceleration. Okay children, next thing is I am going to write one more thing here children. Here I want to write here now force. Force. Children, force formula is what? F is equals to ma. F is equals to ma. That means mass into acceleration. Mass into acceleration. Children, what I told you, for mass what is the dimension formula? M. Clear? And what is the acceleration for what is the acceleration? LT inverse 2. What have to say? LT inverse 2. Clear children? Force, this is another quantity. What is the formula? F is equals to ma. M into, for the acceleration what you have? LT inverse 2. LT inverse 2. That's why here we will write LT inverse 2. LT inverse 2. This is the dimensional formula for force. Dimensional formula for force. So again, to children, you observe this one. F is equals to ma. To write the dimensional formula of force, you must have idea about the what is the dimensional formula of mass and what is the dimensional formula of acceleration. Okay children, so m into a. So already we know about the mass m, and acceleration is already explained here, LT inverse 2. Then what write? MLT inverse 2. So MLT inverse 2 is the dimensional formula of force. And now here for mass what is the unit? Kg. And for L length what do you write? Meter. For time what do you write? Second. Already inverse 2 is there. Kg, meter, second inverse 2. That means when we have idea about the dimensional formula, we are able to write the units also. For mass kg, and for length meter, and for time second. So here generally what write? This is known as Newton. Kg, meter, second inverse 2 is called, what is that? Newton. So children, so this is simply about the dimensional formula and dimensional equation, and how we can write the dimensional formula for different physical quantities. How we can write the dimensional formulas for different physical quantities. Children, I explained only few of the dimensional formulas. You must try to write the remaining dimensional formula for different physical quantities. So children, if you have any doubts, I will do another videos, some more videos regarding the dimensional formulas. So this is the first part of the dimensional formula video. So I hope you understand. If you can understand this one, like, share and comment the video, and subscribe my channel for latest updates and press the bell icon for latest notification, children. So I will do some more videos regarding the dimensional formulas. You must follow it. We will meet in the next video with some other topic, same topic. So see you soon there. Bye. Take care.